Good morning, good afternoon, or good evening, depending on where you are in the world. And thank you for joining this learning experience brought to you by Fairwinds. My name is Cody, and welcome back to Techstrong Learning. Before we dive in, I have just a couple of notes to review with everyone. First of all, we are recording our session today. So if you miss any of our conversation, if you'd like to watch again later, or of course, if you'd like to share with the rest of your team, we'll be sure to send you an email with a link to access our recording shortly after we conclude this live session today. Now, if you'd like to get involved, there are a couple of ways to do so. Your first option is to use the chat tab on the right side of your screen. And of course, when you find that chat tab, let us know from where in the world you're joining from today. If you have specific questions, and I'm sure you will, we want you to send those into the Q&A tab on the right side of that chat section. If you put your questions in the chat and they happen to disappear, I'm just moving them over to the Q&A, so worry not, we've got all those saved. We do have 2 polls that will be launching throughout our discussion today, so keep an eye out for those. And we will be selecting 2 of our most engaged attendees to win a $50 Amazon gift card. So thank you in advance for your chats and your questions, and thank you in advance for filling out our post-webinar survey. All 3 of these things will make you eligible for our giveaway. So moving into our topic today, we are monitoring in Kubernetes, the what and why of monitoring. Now I'm joined today by Robert Brennan, Vice President of Product Development at Fairwinds, and taking us through our demo and helping us in this conversation today is going to be Dexter Garner, Sales Engineer at Fairwinds. So Robert and Dexter, really appreciate the both of you joining us here on Techstrong Learning. Robert, are you kicking us off today?
Yeah, so we're going to be talking about monitoring in Kubernetes. Hopefully that's what you're here for. And Dexter is going to help us take us through the slides.
Awesome. Yeah, Cody, appreciate the introduction. Really looking forward to digging in. We already touched on the subject matter, but we're going to be speaking about monitoring in Kubernetes, the what and the why. So without further ado, let me jump on in. There we go. Cody gave us a brief introduction. Everybody, welcome. My name is Dexter Garner. I'm a sales engineer here at Fairwinds, and I'm joined by Robert, who's our Vice President of Product here at Fairwinds. So,
hey, folks. Yeah, my name is Robert Brennan. I lead up all the software efforts on Fairwinds Insights, which is our software platform. I've been working with Kubernetes for about 5 years now, and an open source for about 10 years.
Awesome. Thank you, Robert. So first, let's start with a little introduction about Fairwinds. As the slide says, we are the trusted software and services partner for running and optimizing mission-critical application on Kubernetes. And let me go to the next couple of slides. We'll expand on what that means here in a little bit. So as stated on the last slide, there are 2 arms of Fairwinds. Firstly, we have our software side. Our software offers platform engineers the ability to standardize and enable development best practices, which can lead to positive business outcomes like increased development velocity and cluster reliability. We also have a large feature set that focuses on FinOps, right sizing, and all things cost allocation. And then Fairwinds Ops, our mission. Secondly, Fairwinds has a full services arm. We manage Kubernetes clusters, and we offer monitoring and 24-pager coverage as well. So next, I'm going to pause here, pass it back to Cody. Cody's going to put up that first polling question, and if everybody would engage with that.
So the question is, how much of your infrastructure is on Kubernetes or planned to be migrated to Kubernetes in the next 6 months? It could be none of it, some of it, half of it, or all of it. Some pretty interesting results here. Seems like most of you are leaning towards some. We still got results coming in here. So it sounds like a few of you are saying none, which is a little interesting, given that this is a talk about Kubernetes. But I'm glad you're here. We can tell you about all the benefits of using Kubernetes. A good chunk of you are looking to migrate all of your infrastructure to Kubernetes, which is great. It's very nice to standardize on that single platform. And then I think most seem to be in that middle bucket of some to half, which is very reasonable. I think that's where we see most companies going. They have a lot of legacy stuff where it's just easiest to run it on their existing infrastructure, but all new applications or some existing applications are migrated over to Kubernetes. So this is very much in line with, I think, what we see in the market.
Yeah, absolutely, Robert. And it has every year the Kubernetes adoption grows more and more. So we understand that sometimes migrations of larger companies can certainly take time, but it's exciting to see how the Kubernetes community continues to expand. So moving forward, we're going to be talking about the big three. I'm going to be passing this over to my colleague Robert. We're going to be discussing observability, of course, monitoring and alerting as well. So take it away, Robert.
Cool. Yeah. So this is a presentation about monitoring, but there's two kind of related topics here around observability and alerting that both kind of tie into monitoring. So at the far end, we have observability, where we're really gathering up data from our environment in order to understand what's going on inside of our production applications, understand how they're behaving, how that behavior is changing over time, things like that. So it's really about gathering a bunch of raw data into a single place where your developers can look to see, what is the current state of things, and understand, is something going wrong? Is something happening different today than it was yesterday? There's four basic pillars of observability: events, logs, traces, and metrics. Events are like specific things that are happening over time in your cluster. So that could be, or whatever your application is. That could be, an event within your application, like a new user signing up. It could be something like, a job spinning up or a cron job firing off. Anything that happens at a specific point in time is an event. Logs are spit out by every single one of your applications. Anything that can print a standard out or standard error, you're going to want to be able to see those messages over time, index them, search them, things like that. Traces follow, particular request throughout its life cycle as it hits many different applications or many different microservices. So basically being able to follow the path it takes through your system. And then metrics are basically any numerical data that can be measured over time. So things like latency, CPU usage, anything like that, you can be gathering, like basically a time series of data to understand how those numbers are changing over time. Stepping in, one layer deeper, we have monitoring. This is where you take all that raw data and you start to package it up in ways that make sense for your team to really highlight the things that matter to your application, right? So there's probably a lot of logs, a lot of metrics, et cetera, that don't really matter and can kind of be filtered out. And then there's some that are like really important to the health of your application. You really want those brought front and center. And so you start to build some dashboards, you start to define some key indicators in order to understand how well your application is performing, how healthy it is right now. So this is really when you start to dig through all that raw data and surface up the stuff that matters to your team. And then finally, at the far end of the spectrum, we have alerting, where we're going to take some of those key indicators, and if they go out of a normal range, we're going to send an alert. Maybe page somebody who's on call, maybe just send a message to a Slack channel. But figuring out what are the behaviors of our application, what are the normal metrics, where if we see something out of line, if we see this type of event, or we see this type of metric go out of band, then we want to make sure we're proactively alerted about that and not just wait for somebody to go and check the dashboard and notice it. Cool. So starting with that first pillar, we can talk about what observability looks like in Kubernetes. So we talked about these four pillars: events, logs, traces, and metrics. And within Kubernetes, there are specific things you kind of want to look for within each of these categories. So from an events perspective, you're going to want to look for things like scaling events. So that could be a workload scaling up or down, meaning like a new pod or new instance gets added for that application or removed because there's not as much traffic on it. Could be a job firing off or a cron job firing off. Could be admission events. So every time a new resource is admitted to the cluster or a resource gets changed or deleted inside the cluster, there are a bunch of events that trigger like that within your Kubernetes cluster, and it's good to have eyes on those event streams. For logs, pretty straightforward. Every single pod running in your cluster generates logs. Anything it prints out to your standard out or standard error is something that you can see. either with kubectl or by basically ingesting those logs and putting them into an external platform like Datadog. Traces, there are some tools for tracing in Kubernetes like Jaeger. There's some open protocols here, but basically being able to, if you've got multiple services running in Kubernetes, so you've got a bunch of microservices, as a request comes in, you can trace how that request bounces from service to service as it gets served back to the user. And then for metrics, there are a ton of metrics that you might measure within Kubernetes. I think some of the big ones are things like the CPU and memory usage for each pod, CPU and memory pressure on every single node in your cluster, things like latency of traffic, number of requests coming in, number of bytes going in and out of each pod or each node. There are a million different metrics that you can measure here. Cool. And so we can see there's a lot of solutions for observability in Kubernetes. Pretty much all of these will gather up data from inside your cluster and centralize it into a single place. The big three we've pulled out to the right, Prometheus, Grafana, and Datadog. Those are some tried and true solutions here, but there's a ton of stuff that you might look through. I see somebody has asked about Zabbix in particular. You can see it's on the list. We have not tried all of these solutions, so we can't tell you, which one's best or which ones you should go with. We are users of Datadog internally, as well as Prometheus and Grafana. We use them for different things. So those are the ones we have the most experience with. Those are probably the most tried and true solutions within the community, but there's good reasons to look at any of these solutions. So I'd encourage you all to experiment here. Cool. So shifting a little bit further to the right and talking about monitoring, there's 4 golden signals when it comes to monitoring: latency, traffic, errors, and saturation. So latency is how much time does it take once a request comes in for you to serve that request. Traffic is how many of those requests are coming in, how much demand is there being placed on your system at any given point in time. Errors are how many requests are being responded with some kind of error message, maybe an expected error message like a 404, user made a bad request, or an unexpected error like a 500 error, something went wrong within your system that probably shouldn't have. And then finally, saturation. How full is the system right now? How close are you to basically running out of space, running out of the ability to serve users' requests quickly, and maybe close to tipping over to having more errors and more latency. So within Kubernetes, we mainly map to notions of saturation and errors. Those are the things that you're going to be most concerned with. Errors are things like pods restarting, memory out of memory errors, pods crash looping, not being able to pull their container, maybe failed requests to the Kubernetes API. So somebody tried to deploy something and that request was rejected. Those are the types of errors you're going to be concerned about. And then saturation, things like whether your nodes are scaling up, maybe you're close to your threshold for the maximum nodes that can be in your cluster, new pods scaling up. Typically, Kubernetes does a good job of dynamically scaling, but you will typically set limits around how many replicas can be available for a particular application, how many nodes can be provisioned for your cluster in order to prevent massive cloud bills suddenly appearing, and making sure that you're roughly within band for the minimum and maximum number of replicas you've set, or the minimum and maximum number of nodes you've set is important. If you're getting close to the maximum, you might need to adjust that maximum in order to make sure that you're able to handle all the demand on your system. Or you might need to fix some issue where maybe there's not actually that much demand for your system and somebody introduced a memory leak or something like that, and that's why things are scaling up so much. So important to look at those saturation levels within Kubernetes. You can also look at latency and traffic within Kubernetes, seeing how many requests are coming into your Kubernetes API server right now. That might be an indication that something's going wrong. If there's a huge increase in traffic, somebody's like stuck in a deployment loop, constantly trying to deploy to your system, something like that. And you can look at how long it takes for your Kubernetes API server to serve that traffic, how long it takes for pods to come up when they do get put into the cluster. It could be an indication of some pressure on your system. So all 4 of these are good to measure within Kubernetes, but errors and saturation are the really, really important ones. That's where Kubernetes clusters tend to fall down.
Awesome.
Cool. In terms of what to monitor, this is advice from Google. Basically, making sure that you're measuring all 4 of those golden signals is the really important thing. At least making sure that when one of those signals is problematic, that somebody's getting alerted or it's highlighted on a dashboard. Super important. But those 4 golden signals are the big things you want to monitor. Those are the big things you want to have a dashboard up for, making sure that you've got eyes on. So monitoring in Kubernetes is a little bit harder than in the old world where you have static servers serving each application. The big issue with Kubernetes is that it's ephemeral. So none of the resources that live in Kubernetes are long-lived. The nodes that they're running on can disappear at any time. The workloads that are running in there can disappear at any time. So in the old days, you might have set up a server, released your application to that server, and then you set up monitoring for that server specifically, right? You're watching how much memory and CPU that server is using, how much network traffic is coming into that server, et cetera. But with Kubernetes, the specific servers that are running your instance, that the nodes are constantly moving in and out. They might get removed, and the workload might get rescheduled onto a new server. And so you're really you're setting up monitoring for the cluster itself. You're basically connecting into a more generic abstraction around memory and CPU usage in order to understand what's going on inside of my cluster. Another challenge is that it's distributed and multi-tenant, and this means that there's your Kubernetes cluster is spread across many different nodes, many different servers that are hosting your applications, and it's also multi-tenant, meaning you've probably got multiple different teams deploying into the same cluster, and all those workloads are mingled together. And so if you see, say a single node suddenly has a bunch of CPU pressure on it, it's not clear, what team owns that node. No particular team owns that node. It could be the core Kubernetes infrastructure that's putting pressure on it. It could be application A, it could be application B. And so, it's hard to go from, okay, we have this issue of CPU pressure. Now, who do I blame? How do I figure out what the root cause is? Because there's so many different things commingled on that single node. So that's a pretty difficult issue to get around with Kubernetes. It involves a lot of kind of internal knowledge as to how your cluster's behaving. There's also a lot of built-in fault tolerance for Kubernetes. So a lot of the things that you might have worried about in the old days, you no longer really need to worry about. So this can lead teams to monitor the wrong things with Kubernetes. So for instance, pods restarting in Kubernetes is not as catastrophic of an event as it might have been in the old days where you had, basically one server for each application. If that pod restarts, typically you've got multiple instances running. Traffic can easily be diverted to another pod. Pods restart for stupid reasons all the time. Sometimes a node gets rolled and the pod has to restart. It's almost expected behavior in certain cases in Kubernetes. So having a monitor for every single pod restart or getting alerted for every pod restart is probably overkill. But that said, if a pod's restarting constantly, maybe it's running out of memory every 30 minutes, that's probably a signal that you do want to pay attention to and get eyes on. And then lastly, there's just a ton of metrics in Kubernetes, as we mentioned before. So figuring out exactly what you need to measure, what you need to have dashboards up and running for is a little bit of an art. We're constantly discovering new signals in Kubernetes that we can pay attention to and monitor. So this is it's kind of a fire hose to dig through and find, what are the good metrics? What are the important metrics for us to pay attention to? Cool. And then lastly, we want to talk a bit about alerting. Figuring out what to alert on is definitely a bit of an art form, and it's a rough trade-off. If you don't alert often enough, then you're going to risk having an outage that nobody gets alerted for, and nobody wants that. Nobody wants to learn that their site's been down for 2 hours before anybody got paged. And then alternatively, if you alert too much, you run the risk of basically pager fatigue. You run the risk of burning out your SREs, burning out your development team, anybody who's carrying a pager, and you run the risk of people starting to ignore the alerts. That's a serious problem if you're sending an alert every 30 minutes for something that's not actually actionable. The team's going to learn to just ignore their pager or ignore that particular alert. And when it's actually a problem, you get this boy who cried wolf scenario where nobody actually jumps on it. And so we tend to advise folks to hold to 3 guidelines when thinking about alerting. First off, you want to alert on things that are going to affect users. So if this is an outage that's really not going to affect any of your users, it's not going to affect your revenue, it's not going to affect your bottom line, then don't page somebody at 2 in the morning. You don't want to wake somebody up to fix an issue that could have been fixed tomorrow. Next, you want to alert on things that are actionable, things that actually we can do something about, right? If you just alert on something that nobody can really do anything about, then whoever gets woken up at 2 in the morning is going to be frustrated. They're just going to have to mute the page and move on with their day. And then lastly, things that require human intervention. If you can automate the response to this, then you probably should. So like, for instance, if you've got a workload that maybe is becoming saturated and needs to scale up, you probably just need to change your auto scaling mechanism so that it can scale up on demand, rather than having an SRE wake up in the middle of the night and like change number of replicas from 3 to 5. That's a pretty annoying thing for an SRE to have to do. So if the SRE is waking up and just like looking through a flow chart or looking through some playbook saying like, if this happens, then do this, probably that's something you can automate with a bit of code, or you leveraging some like auto scaling capabilities or some other behavior within Kubernetes. So alerting should really only happen if something really unexpected is happening and you don't really know, or the system doesn't really know how to handle that automatically.
Great. Thank you, Robert. So we're going to let you catch your breath for a minute and jump into the second polling question, which is, what common Kubernetes challenges are you trying to solve today?
Cool. So it sounds like in terms of challenges, folks are mostly lacking standardization, which makes their clusters more difficult to manage. Very common problem we see, especially at larger organizations, larger enterprises, where you've got many different teams, sometimes provisioning their own clusters, or different app teams are all responsible for deploying their own application, and they do it their own ways. A lot of folks, it seems, have developers deploying misconfigurations and vulnerabilities, running into tech debt problems. Again, a common problem that we see, especially with folks who haven't put anything like policy into place. And it seems like some issues with over-provisioning workloads leading to cost overruns, and too much time being a help desk for Kubernetes to the development teams.
Great. No, really good feedback. And I think the next 5 to 10 minutes will be super relevant. I think our solution, not to self-congratulate or pat ourselves on the back, I think it'll be super relevant to everybody's responses there. So next portion of the conversation, I'm going to give everybody just a quick walkthrough of our solution. So again, the first aspect of our business here at Fairwinds is a software called Fairwinds Insights, and it helps platform teams run Kubernetes and standardize and enable development best practices. A lot of these lead to positive business outcomes. Again, if you're a platform engineer, being the Kubernetes help desk can reduce your time to focus on your tasks at hand. You can build up that tech debt, and we also can help to improve some developer experience. And then also, talking about over provisioning on Kubernetes, Kubernetes often can become kind of a black box when it comes to cloud spend. So wildly over provisioned workloads, developers just kind of setting, egregious amounts of compute power or memory to a particular workload and never revisiting some of those deployments. So I'm going to just exit out of this screen for the moment and jumping into a secondary tab, which should be Fairwinds Insights. And Robert, can you see my screen? Okay.
Yep.
So this is kind of the landing page for Insights. A couple of things to just kind of point out is we are cloud agnostic, so we can support any running Kubernetes on any of the major clouds. We also offer an on-prem version of the solution. It's also a kind of single pane of glass tool. So typically we'll have platform engineers owning insights. They can kind of control the levers behind the scenes, and the entire organization gets the benefit of those enforced standards or policies. So we kind of operate on 3 key tiers. That would be security. So we have a number of security policies running behind the scenes. Reliability. So do we have liveness or readiness probes configured? And then things, efficiency checks, like do we have CPU requests and limits set? Maybe we want to have proper labeling conventions on workloads. So we have some sort of understanding as to who's running what and where. So first aspect, we're running a number of tools. Basically, you would deploy directly into your cluster, and all of your in-cluster observability. So that's a keyword that we've touched on here. You can think of action items as kind of a home inspector. So we're not necessarily going to go out and fix the problem, but we're going to try to be preventative about what could cause the solution, or cause the problem rather. So we have a number of checks, like we have teams that want to ensure that we have pods distributed across fault tolerant zones. So this would be a pretty common packaging of all of the findings. We'll tell you exactly where that event or issue has occurred. So again, finding like configuration sprawl. Oftentimes you might have an issue in one of your, maybe you're running Kubernetes at scale. You have 50 to 100 clusters, and you have an issue that's occurred, but you have no idea where it's taking place. We'll give you that geolocation information. Additionally, we're always going to provide a description of that issue. So if you have a newer development staff or a team that's not necessarily Kubernetes experts, they can read up on that issue. We'll always provide relevant documentation that's linked to Kubernetes.io. So you're not reading that 5-year-old Stack Overflow that's completely irrelevant. And then we always provide inline remediation advice and guidance as well. So this is nice to cross-reference against your deployment manifests and fix the issue at the source. Another nice thing as well, so this would be some of the observability aspect. We can do event triggers. So let's say, for instance, you have a security team internally and you want to be alerted when there's a new container CVE. We have a number of first-class integrations. So we understand a lot of teams are using tools like Datadog or ticketing systems like Jira to consume all their metrics and go about their daily flow. You can automate the ticketing or creation of events for specific findings, and you can handle those natively within your daily workflow, which is really nice. So this is going to be some of the observability aspect. We also have admission controllers, so you can manage some of these policies and prevent some of those issues from ever entering your cluster to begin with. So we have a number of out-of-the-box checks or policies. So if your team doesn't want to write or manage their own policies, we can certainly help you all directly out of the box. We also have integrations with OPA. So if you wanted to write anything custom, you could certainly do so. And we can manage all of your admission events. So let me just show you a brief example. I'll go back to a later time period. And I'm just going to select some of the failed admission events. So this would be an example of an attempted deployment. So you can see there's, there's 14 failed policies here. You can either block admission based off criticality, or you can simply warn. So if you said, hey, maybe CPU requests or limits aren't set on this, we want to be alerted on it, but we don't want to hinder deployment or slow down some of your speed to market, you can simply warn. Additionally, maybe you want to ensure that things aren't deployed in a default namespace, and if somebody tries to do so, you can fail that deployment. That would be an example of a critical action item. But much like the previous example, we'll show you again a description, how to set it or how to fix that issue. This one being fairly simplistic. Change the namespace. Don't go in default. Be an example of being proactive, fixing those issues before they enter the cluster. The last aspect of insights that I did want to touch on would be some of the metrics. So efficiency, FinOps has become super relevant, a very hot topic. Everybody wants to know about their cloud spend, especially in Kubernetes. So jumping into costs, the two big use cases that we hear frequently are showback or chargeback models. So what is an application team spending? How much does an application cost? Maybe they want to charge back a business unit. You have an internal FinOps organization and you wanted to understand, hey, if application A runs over their allotted budget, there's going to be some big internal questions. So you could allocate costs based off of workload label is a very typical use case. We also hear namespaces. So let's just say we wanted to understand Jenkins production across all our clusters. And you can zero that down. We have a small build cost in our demo environment, but this would be 30 days. You can then look and say, all right, well, which clusters are costing us the most? Maybe you want to dive into an individual cluster and analyze the workloads that are comprising most of that cost and see if they can be right-sized, which leads us to our second most important use case, which would be right sizing. So cloud spend kind of boils down to a few things. It would be, savings plans. Are you running a savings plan? Are you doing spot? And then, how many nodes are you running? Are you running fewer larger nodes? And then are you properly setting requests and limits on those workloads that are sitting on the nodes? All three of those are going to, ultimately comprise your cloud costs. So let me just jump into a quick example of a right sizing recommendation. We have a number of quick views. Maybe we wanted to jump into top workloads. This is going to present you with your 10 most expensive workloads across all your clusters. And then your most expensive one over here on the far left. And I'll click on that for example. So for each workload, again, we're collecting metrics for 13 months. So you can analyze this at as large a date range as you would like, or maybe you're load testing and you wanted to look at it on an hourly cadence, you can do so. We're going to present recommendations for both CPU as well as memory. And that's going to be based off of your actual workloads cluster or your workloads compute and memory utilization. So your team gets these metrics, you get to analyze those, and then you get your recommendations that are generated based off of a concept called quality of service. So if it's a really important workload, it's integral to your application's performance, you need to make sure it's online. You can select critical or guaranteed. Those are going to give you your 95th percentile recommendations. Inversely, maybe you're running in a development environment. You want to have burstable recommendations, setting your requests towards your average usage and then your limits up towards your maximum usage. Those are very popular use cases as well. The nice thing about all these events and metrics, it's like we're getting all this. It might be information overload. How do we actually take action on that? And that's going to be the integrations again with Jira, Slack. We can set automated alerts for over provision workloads. So your team isn't responsible for coming in here every day and saying, what should I work on next? They can be met in their daily flow. So again, that's just a little overview. We do have a free tier if you guys want to check it out. Feel free to. Let me just zoom in on that a bit. It's 2 clusters, 20 nodes, so you can test it out at a pretty sizable scale. And feel free to ask us any questions on our community Slack. But I think now I'll turn it over to Cody and handle some Q&A, but I appreciate everybody's time.
All right, so before we dive into our questions, I do want to say that that link on that last slide has just been posted to the chat by Dave, so I'll go ahead and pin that to the top as well. So we've got lots of great questions, and this one was timely. This one's for you, Dexter. Which cost is getting compared there? There's a column for the cost on that demo.
Let's see.
I think the question is what does that cost difference represent? And it's basically, so for every workload, we not only see how much is it costing you today, but we also have a recommended cost. If for instance, if you set your requests to one CPU for this workload, and we see it only is actually using half a CPU, you've basically got half a CPU of waste there. And so the cost difference says you could be saving 50% on this workload if you shrink your request down. And so the cost difference is a good indicator of, if you took our suggestion, you could be saving money on this workload. Or in certain cases, this workload seems to be under provisioned. It's constantly running out of memory and CPU, and you should actually expand a little bit.
And to expand on that, we have a couple of integrations with cloud providers, so we can directly consume your cloud bill. So we're analyzing the cost of a running workload as it's been operating over a period of time.
Perfect. Thank you guys for that. We'll move back to some questions that we've received earlier on in our presentation. Mark D asks, Prometheus or Grafana versus monitoring tools from Fairwinds?
Yeah, this is a great question. So I would say Prometheus, Grafana, Datadog, and Fairwinds complement each other very nicely. So Prometheus and Grafana or Datadog, alternatively, are really going to do what we like to call like tier 1 monitoring. Like they will tell you if your house is on fire right now, if your applications are crashing, if they're about to crash. Like it's a very it's a place where you want to be if there are problems right now. Insights is more like a home inspector. It will tell you if you've got bad insulation and everything's made of asbestos, and you really need to replace some things within your infrastructure, make things better, fix vulnerabilities, replace over-provisioned workloads, right-size their settings, things like that. So it's really a complementary solution. We're highlighting all the things that you might have done wrong in your infrastructure as code, vulnerable container images, stuff like that. So it's a complementary solution is the answer to that question.
Awesome. Looking at our next question from Dibyanshu. What would be the best framework to choose when we have to finalize observability for the Kubernetes app and area of shared responsibility matrix? Who owns what that app instrumentation for metrics and dashboard alerts on different metrics and logs?
Yeah, this is a great question. I think there's a couple of things in here. The first is asking about the best framework for observability, and that's kind of an open question. We certainly aren't going to recommend one specific solution, but a few of the big ones out there. I think Datadog is one that we use internally for our applications. It works very well, works out of the box. It's kind of expensive, but it's worth it. There's also open standards like OpenTelemetry. So there are some great solutions there, both open source and paid. Prometheus and Grafana are a great stack for observability within Kubernetes. So lots of different solutions there. I think it's up to you how you want to balance, ease of use, cost, how well understood the platform is by the community versus some new up and coming platforms that might have some neat new features that the old ones don't support or might be cheaper, et cetera. So lots of different options. It's worth kind of exploring there. We could probably do a whole talk on just different observability stacks. And then in terms of that responsibility matrix, I think it can get a little fuzzy. On one end, you definitely want a platform or SRE team owning kind of the core metrics for the nodes themselves, for the services that are running Kubernetes itself, the control plane, as well as any add-ons that you might have running, like Cert Manager or Nginx Ingress, or basically anything that's running to kind of support applications running in Kubernetes. And then at the other end of the spectrum, if you've got your applications themselves running in Kubernetes, the logs that those applications emit, events like, jobs spinning up for those applications, scaling events, et cetera. This should probably be owned by the application team. They should probably, they're going to have the context to understand what this log message means, if we're getting 500 errors and stuff like that. And there is a little bit of a gray area in between, like, if an application is having trouble scaling, or if it's, maybe running out of memory and CPU, things like that, where there might be might land on the applications team, it might land on the SRE team, depending on what the root cause of the problem is. And so there you're going to really have to see some collaboration between the two teams. Mostly what we see is the SREs monitor those types of things. The platform team monitors those things. And then if they don't see an obvious cause from their end, they'll open up a ticket against the application team and say, hey, your application is redlining over here. Your application is misbehaving. You need to go and fix this thing. But it involves a lot of collaboration between the platform team and the application team in order to have a good dynamic there. It's a great question.
We actually had a follow-up from Divyanshu. So how do we baseline when we'll be adopting any adaptive golden signals tracking?
Yeah, this is also a great question. Baselining is hard. I think it really speaks to the fact that this is always an ongoing process. It's not like you just set up monitoring once and you're done. You have to constantly be refining what you're tracking from an observability standpoint, what you're showing in your dashboards and things like that from a monitoring standpoint, and what you're alerting on. This is just a constant flywheel of refinement as things go on. So to start, really just making sure you're tracking those 4 golden signals and looking at what normal behavior looks like. If you're launching your application today, just start looking at those things and seeing what normal behavior is for that first week of your application's life. And you probably want to be in there looking at those dashboards constantly in those early days. Because you don't know what normal looks like yet, and you don't know what danger looks like yet, and so you're probably not monitoring the right things. You're probably not alerting on the right things. So you want to be at that beginning point, really experimenting and figuring out what does a baseline look like, and then once you have a good intuition for how your application behaves under normal circumstances, that's when you can start to set those thresholds and say, okay, here's a normal band for my application, and here's where I want to alert. Or here are the things that I keep looking at over and over again, and I'm going to make a dashboard that shows those things front and center. So like I said, it's an ongoing process.
Perfect. Let's put on our comparison hat for just a minute here. And what features of Fairwinds stand out from other available Kubernetes monitoring tools in the market?
I think ease of policy management. So adopting policy at scale and policy exception. So managing exceptions and not slowing down development efforts is a pretty big challenge, probably larger than most would think. And then additionally, I think just engaging into development workflows. We call it developer enablement. I'm sure there's multiple different acronyms or terms you could use for it, but how do you actually get your team to take action on findings or fix issues? And that's 3/4 of the challenge, as opposed to just flooding folks with data. So,
yeah.
And Robert, I don't know if you'd expand on that.
Yeah, I think the developer experience one is a big piece of it. A lot of the existing observability and monitoring solutions, they're looking at your live cluster and surfacing data into some dashboard somewhere. We also look at the live cluster to understand that as like a source of truth. But we also integrate into CI/CD systems. So we'll look at your actual infrastructure as code as it's being changed before it gets into your cluster, and we can surface issues there. So if a developer is, say, creating a new workload that's going to run as root, and you don't want things running as root, we will stop that pull request from getting merged. Or if they are modifying a workload that's requesting 10 CPUs and they really only need 1 CPU, we'll surface that finding as they're making a pull request and say, hey, you should really change this to only 1 CPU because we've been watching this workload in production and it's not really using as much as you've requested here. And so really getting into that workflow is super helpful. And we also integrate into ticketing systems like GitHub issues and Jira and Azure DevOps, so we can surface findings to developers kind of where they already live, rather than your SRE team having to like Slack them or like send them a link to our application. You can just open up an issue against their systems with all the relevant data.
All right, so Dexter, during your demo, you mentioned not naming namespaces with the default. We had a little bit of pushback in the comments, but Nadia asks, what are the best practices to follow for namespaces?
Yeah. Go ahead, Robert.
So this is a really interesting question. Everybody does it differently. I think the first best practice is to use namespaces. We've seen companies that basically every app and everything gets deployed into the same namespace, the default namespace, and it just creates a lot of headaches. It's just everything's commingled together, and there's not really any ability for particular teams to separate things out, to permission things differently. So namespaces really provide this nice separation of concerns to make sure that app team A doesn't have access to app team B's stuff. They can't, fight each other, things like that. You can apply policies for namespace A that don't apply to namespace B, et cetera. I think at the very least, separating namespaces by teams or by applications is a really good practice. There's also a notion of hierarchical namespaces, which I have not actually seen organizations leverage all that much, but something I'm really interested in, basically where you can create a namespace and then create sub namespaces within that. So you could have like one namespace for all your applications and then a sub namespace for each individual application, or a sub namespace team and then a sub namespace for each application those teams manage. So there's some really interesting things to do with namespaces. Just using them is a big step forward from that, though.
And then the second iteration of that would be adding labels to workloads, whether it's a team, an owner, maybe it's a cost center. So there's additional ways to track or attribute resources to a business unit or individual.
Yeah, that's a great point. That's a great way to be able to look at similar things across namespaces too. Like you might have apps labeled with like staging versus production or something like that, and that can help be a good signal to your teams to as to what's more important.
So what Fairwinds insights using in the background to gather these events, and can this information be sent to any other monitoring backend?
Yeah, this is a great question. So we have an agent that runs inside the Kubernetes cluster. That agent runs a bunch of open source. So that's projects that we manage, like Polaris and Goldilocks, as well as some third-party tools like Trivy and KubeHunter. So basically, we're basically using this open source to scan the live cluster and send the data back to our platform. The agent is pretty heavily tied to our platform, so you can't just like install the agent and send the data elsewhere. But like I said, it's all using like existing open source tools. So you could wire up that open source. You could take, say, Polaris, which detects misconfigurations like containers running as root or missing liveness and readiness probes. And you could look at Polaris results on your command line. You can set up a Polaris dashboard in your cluster, or you can send the results to any other system.
And then a lot of the policies and supporting checks are based off of popular compliance standards. So they are industry wide best practices.
Are these insights out of the box? Are these out of the box insights, I should say?
Yeah, so I think the question is specifically related to the action items that Dexter was showing. So all those action items you see in the platform, there's about I think around 150 different types of findings that Fairwinds Insights can surface. Those all come out of the box, mostly from open source that we leverage, but partly also from proprietary tooling that we use to generate those action items. And then you can also generate your own custom policies using OPA or Caverno or Polaris. So if you have like a special labeling scheme that you want to apply to all your workloads, you can write a custom policy for that and generate findings. But we have a ton of policies that come right out of the box.
So Nadia asks, your portal says right-size container workloads, automate security and compliance, and establish policy and guardrails. Can we adjust and change the auto-generated policy and guardrails?
Yeah, absolutely. This is totally a feature of Insights. It's one of the features we see folks use a lot of the time is I really care about this set of policies because I'm SOC 2 compliant, but I don't care about this set of policies. Or I really care about containers always using the right amount of memory and CPU because I'm very cost conscious right now, but I'm not really worried about security just yet. because we're still just a scrappy little startup. Whatever it is, we see folks applying different sets of policies. We also see them applying different sets of policies to different workloads. So they might be much more concerned with the security of their production applications, but not the security of their staging applications, because that cluster is hidden behind a firewall. And so they might apply some security policies to production that they don't apply to staging. And so you can kind of mix and match and decide these workloads get these policies applied to them, and these workloads get these policies applied to them. And you can write your own custom policies and decide which workloads they apply to as well.
Robert hit on 98% of it, but one thing I would add is that we do have documentation on what we view as the crawl, walk, run adoption of policy in Kubernetes. Again, with everything cloud native, there is an approach to adopting it, and we understand that it is it can be a bit of a challenge and an internal a shift for a company to adopt something like policy.
All right, so Lynn has sent in a question, and it says, why is monitoring crucial in the context of a Kubernetes platform, and how does it contribute to the overall health and performance of containerized applications?
Yeah, so I would say monitoring is crucial, kind of no matter whether you're using Kubernetes or not. If you're not monitoring what's going on inside of your application environment, you're at risk for an outage, right? So it's super, super important to have eyes on what's going on. What are your general health metrics? How do you know that your application is behaving properly? I think the worst case scenario is you have a hard outage, your users can't access the app, you're losing revenue by the minute. That's kind of a worst case scenario, but even more scary is a scenario where things are going wrong, but you don't have a full-blown outage. Maybe like 10% of your users are struggling to use the app. They're getting error messages. The platform's saturated. So it's not obvious. You're not getting reports right away that like, hey, something's wrong, but all your users are having some kind of degraded experience. And you're not able to see that because you don't have the right metrics up showing that like latency is through the roof, or whatever else, your database is under pressure, whatever else might be happening, that's degrading user experience. And then that bad user experience can go on for hours or days before someone on your team notices. So very, very important, no matter whether you're using Kubernetes or not, to have that monitoring in place.
Awesome. So Dexter alluded to a crawl, walk, run method, but what is the average setup time to go from start to useful?
Robert, you want to handle that, or you want me to take that one?
Yeah, I can handle it. I would say the average, there's a very quick setup time where it's basically, you just install a Helm chart and you're off and running. We're gathering up kind of like all the defaults that we think you should be monitoring. I would say some users will take, a couple weeks to fine tune all those results and figure out, exactly, I want to monitor X, Y, and Z. I don't care about these other things. So I would say, 2 to 4 weeks is usually what we see takes that initial setup period as a customer's onboarding. But again, you see results within 15 minutes if you're just kind of getting off the ground for the first time.
Yeah, definitely a big difference between observability, so viewing things in a passive sense, and then enabling things into an actual enforcement. And a lot of that depends on companies' release cycles and how they want to adopt things. So typically we do see like an observability period of a 2-week sprint, and then maybe going, following up to the next sprint, actually running 1 to 2 policies in enforcement mode.
All right, we've got just a couple questions left, and we've also got just a few minutes left as well. So we'll start bringing things home slowly. Detlef asks, do you have some sort of backup system integrated to export whole clusters or some nodes?
We don't have a backup system like this. I think there's a project called Valero that does something along these lines. Generally speaking, though, we advise folks basically to store everything as infrastructure as code. So any cluster that we manage, so as Dexter said earlier, not only do we have this software platform, Fairwinds Insights, that we've shown you all, we also have managed services where we actually run Kubernetes clusters for our clients and manage the control plane, as well as a lot of add-on infrastructure. And the way we manage things is entirely as infrastructure as code. So if one of those clusters were to disappear off the face of the earth, we can recreate it within minutes just by taking all that infrastructure as code and reapplying it to a brand new cluster. So that's really the way you should be thinking about a sort of backup strategy, is that kind of all your state is managed in a Git repo somewhere, so that if your cluster dies, disappears, totally fails, it can just be recreated from scratch using that infrastructure as code.
All right, so let's go ahead and touch on our last question here from Abhishek. We are trying to decide between Datadog and Splunk for metrics. What would you recommend? Also, what tool would you recommend for log ingestion from apps deployed in Kubernetes cluster?
Yeah, this is an interesting question. I think I don't want to make a hard recommendation for one or the other, but we are mostly familiar with Datadog. That's what we use internally. I've heard good things about Splunk, but just don't have the experience with it. It does do a great job of just sucking up all of our logs and making them available through Datadog. We can index them. We can decide how long to keep them, things like that. It grabs all the core Kubernetes metrics out of the box. We just install the Datadog agent and it runs. I imagine Splunk has something very similar. So I would encourage you to experiment with both, maybe with just a sample kind cluster or a small Kubernetes cluster to start, and just see which one you like better.
All right, well, we have run through all of our questions and we've got just a few minutes left. So Robert and Dexter, I do want to give each of you the opportunity to leave us with any closing thoughts before we bring things on home. Robert, anything?
I'd just say, make sure you're doing these things. Make sure you're gathering metrics on your cluster, events, logs, traces. Make sure you have some kind of monitoring in place to understand, what do things look like today? How healthy are we? And make sure you've got some kind of alerting in place if, so that if things do go wrong, you get alerted.
All right, Dexter.
I just generally agree with what Robert says, so I'm going to follow that up. But no, I appreciate everybody's time and attention, and the questions have been excellent. So I know, again, there's crawl, walk, run to monitoring, observability, and alerting. So dipping your toes in and then expanding. I really liked Robert's answer to the baselines for starting observability.
All right, well, Dexter and Robert, thank you so much for joining us today on Techstrong Learning. It has been such a pleasure getting to speak with you over the last hour.
Thanks, Cody.
Thank you.
So before I officially release our audience, hold tight for just a second. A couple of reminders: today's session was recorded, and following this program, you will receive an email to access the recording on demand. But you'll also find it on the Cloud Native Now website. Just visit cloudnativenow.com/webinars. I'll point your attention to the top of the chat. You'll see there is a link to the Insights Get Started page, so please click that while you're here. And additionally, if you stick around until we close out, you will be funneled to our survey, and we would love to hear your feedback about our program today. So please just stick around until we close things out. I'd like to thank Fairwinds for sponsoring our program today. And to everyone here, thank you so much for spending your time with us. We appreciate you, and we hope to see you at a future Techstrong Learning Experience. Have a great rest of your day, and you may now disconnect. Thanks again, Robert and Dexter.
Thanks all.
Thanks all.